Okay, sorry class, just now accidentally stopped. Okay, so we continue question 11. All right, so as I said, if P lies on Z axis, then means the coordinate for P will be 0, 0 and Z. Okay? All right, and you are given the position vector of A and B. All this is given in the question. Okay, so let's say AP and PB are lambda mu lah. Alright, so by using the formula, the position vector of OP will be lambda A plus mu, lambda B plus mu A, lambda plus mu, right? This is the formula. Okay, then we submit. Since we have the coordinate for P, 0, 0, Z. Alright, so the position vector of OP will be 0, 0, Z like this. Then 1 over lambda plus mu I put outside. Okay, so lambda multiplied B, mu multiplied A. From here, AB. Okay, so we simplify in a bracket one. So negative 8 lambda plus 4 mu. Like this lah. So 6 lambda minus 3 mu. 5 lambda minus mu. Okay, so they are the same, right? So we just need to compare one of the component. Don't compare this one because we don't know what is Z ma. So you can compare the component for I or J, both can. Alright, so for me, I compare the component for I lah. Okay, so right hand side, the component for I is 0. Left hand side, the component for I is... Okay, hold on. Okay, yeah, can. Class, still the same. Okay, let me check first. Okay, can. By right, it's supposed like this. By right, it's supposed like this. When we compare the I component, alright, when you compare the I component, suppose like this. Because the I component is this whole thing. Alright, negative 8 lambda plus 4 mu over lambda plus mu equals 0. Alright, but because this is 0, so by right is this one. We must write this one, then only correct. Okay, then this one shift here, then 0 lah. Then left this one. Okay, if you compare it's not 0, then we must show the whole thing lah. Okay, if not 0, because this question, yeah, whatever. Okay, there is 0, so when you shift here is 0, so you can get back this thing. All right, so but must write lah, must write. Because as I say, if this is not 0, then we have to consider. Okay, so my answer still correct lah. Okay, so like this, so I shift the lambda, negative 8 lambda to here, become positive lah. So both side positive. So because to find ratio, to find the ratio, so always rewrite it in the fraction form. So we write it in the form in lambda over mu. So lambda, mu shift here. So if mu shift here, 8 shift here lah. So become like this. So simplify is 1 over 2. So if lambda over mu is 1 over 2, then the ratio AP, PB, so this is AP, this is PB, will be 1 to 2 lah. The ratio AP to PB will be 1 to 2. Okay, so this is most of the question that we have discussed is they give you lambda mu. Alright, this question, they ask you to find lambda mu. Actually, SPM question also you did this. But normally SPM question, they use MN. Right? Okay, so this is question 11. The important concept is this one. Alright, so the last question, 12. Okay, so question 12 like this. Say, refer to a fixed origin O. So again, you are given the position vector of point A, B, C. So OA, OB, OC. Okay, find the position vector of point P, which divide BC in the ratio 1, 3. Alright, so if they just say like that, means it's internal. And find the position vector of the centroid of triangle ABC. How to find centroid of triangle ABC. Alright. Okay, so question 12. First part not difficult. So you are given vector A, vector B, vector C. Alright. P is here in the ratio 1 to 3 so means PB one part, PC 3 parts. So means we divide the line BC into 4 equal parts. Alright, 1, 2, 3. So as usual, the position vector of OP is lambda multiplied C, mu multiplied B. Always cross. And lambda plus mu. Alright, so lambda is 1 multiplied OC. Okay, mu is 3 multiplied OB. This is OB. Okay, so after you calculate, no problem, calculate, then you get your position vector of P. Okay, now we go to concept of centroid. So in the beginning of chapter 5 also, I have done a little bit revision of geometry coordinates, or included this one. Okay, centroid of a triangle means, let's say I have a triangle ABC. Alright, so from vertex A, I'm going to join to the midpoint of the opposite side. Alright, so this is BC. Let's say this is a midpoint, so I will join this line. Then from B also, I'm going to join to the midpoint of AC. Okay, then from point C, I'm going to join to the midpoint of AB. So these three lines definitely will meet at one point. Definitely. Okay, if you follow this. So this is the centroid of the triangle. Okay, so centroid of the triangle is similarly to midpoint. Remember, let's say if you have a line. Okay, midpoint M. Remember how to find the midpoint? X1 plus X2 over 2, Y1 plus Y2 over 2, right? So centroid also the same. It's just that involve the third one. Alright, it just involves the third one. Because this is in a 3-dimension, if only 2 dimension, then it's like this. Because you have point A, B, C, right? You have point A, B, C. So X1, X2, X3. X1 plus X2 plus X3 over 3. Then you have Y1, Y2, Y3. Y1 plus Y2 plus Y3 over 3. If 2 dimension, then like this. If 2 dimension. If 3 dimension, you have Z, right? So Z1, Z2, Z3 divided by 3. So this is a formula for centroid. Okay, so just submit now because you have all the coordinate for A, B, C already. Alright, so for X is 1 plus 2 minus 2. See? Over 3. For Y is 1 minus 4 plus 4. Alright, for Z is 1 minus 5 plus 3. See? Over 3. So you get this answer. So if you can find the coordinate of the centroid, then no problem for you to write it in vector form, position vector form, right? So 1/3 of I plus 1/3 of J minus 1/3 of K. Alright, so this is a concept for centroid. Okay, so for today's video, today's lesson, I will stop here. Alright, so if I can finish the next video, so either Saturday or Sunday, I will forward another video in vector about scalar product. So in Form 6 syllabus, vector, scalar product, we have, other than multiply a vector by a scalar, actually we don't really multiply vector with vector. To multiply vector with vector, actually we have two different things. One is scalar product. Another one is, another one is scalar product. Okay, another one is this one, vector product. About multiplication, but we don't really do the multiply thing. Alright, but we have two types, scalar product and vector product. These two are very important in SCPM vectors chapter. Alright, okay, thank you class.